Okay, kids, we're back for video 6 of the College Math 2 final exam review. So with that, we're moving on to problems with little word problems here. So if we have let me get this out of the way. So we have, if a 170-pound person weighs approximately 65 pounds on Mars, about how much does a 9,000-pound satellite weigh on Mars? So this would be one of those problems where this is to that as something else is to something else. You know, we would say A is to B, so A is to B, and where you have a 170-pound person weighs approximately 65 pounds on Mars, so A is to B about how much does a 9,000-pound satellite weigh on Mars. So we've got, however we set this up, we're going to say, okay, C as to D if you want. So we would have A is to B as C is to D. So the ratio would have to maintain itself. So we would just say, okay, well, we would have 175 pounds. So in thinking about this, we would go 175 pounds over 65 pounds. 175 is to 65 on Mars. Not as much gravity there. And then that would have to equal then how much does a 9,000-pound satellite weigh on Mars. So one of the things that I always did with this is I said, okay, well, the Mars is the denominator when I would be doing this. These two things are how much it weighs on Mars. Okay, so you got to keep track of that because it's easy to mix numbers up. So then we have 9,000 pounds is on Mars. So we could make that X. Okay, and we have a little problem to solve here. So now the first thing that you might do is cross multiply. You could multiply by 65x, the LCD, if you wanted to take the whole equation, multiply both sides by 65x, or as I said, cross multiply, you get the same result. So then we get 65x times 175 over 65, sorry, is then equal to 9,000 times 65x over x. So when you multiply by the LCD, then you cancel the common factors that you get. And then in that case, then on the left-hand side, you have 175x is equal to 9,000 times 65. Okay, 9,000 times 65. And I'm going to leave that for just a minute and just get to the solution. So if I want to find x here, all I have left to do is divide both sides by 175. And then that gives me x is equal to 9,000 times 65 over 175. So now you can do the division, the multiplication, multiply the top first and then divide by 175 and you get your answer there. I'll leave that up to you. Next problem. An experienced bricklayer constructs a small wall in 3 hours. The apprentice completes the job in 6 hours. Find how long it will take to complete the job if they work together. So what you have here is you have a bricklayer. So let's talk about the bricklayer first. He finishes one job, constructs a small wall in 3 hours. So one wall per 3 hours, a small wall, we'll say. The apprentice completes the job in 6 hours. So the apprentice, so this bricklayer is experienced, right? They know how to get it done quick. They know all the shortcuts and everything else. Then you have the apprentice, and they do one wall or one job in 6 hours, right? So what they're giving you kind of behind the scenes is a rate. So this is the rate telling you that this guy does the job in 3 hours and the second guy, the apprentice, does the job in 6 hours. Gives you the rate, how fast they get one done. So if we don't know the time, if we let t equal the amount of time, both the bricklayer and the apprentice working together, then remember you have a rate. If I took one wall per 3 hours and I multiplied it times the number of hours, we would get the whole wall done, right? We would get a wall done, or at least 1/3 of a wall. The unit would be 1/3 wall, right? And then we would have the hours would cancel. Walls per hour times hours is just wall. So what I want to do here is I want to take and say, all right, if they're working together, I just need to know the time. The first guy, we have the bricklayer's job. The bricklayer plus the apprentice is equal to the whole job. And we'll just call it a job. So one job for 3 hours is the rate the bricklayer goes to. One job for 3 hours times, we'll say T, the amount of time, plus one wall per 6 hours, the rate times T, is equal to the whole job, which is just going to be 1. They're going to build one wall together. So I've got 1/3 T. I'm going to make this a little bit smaller here. Together. Okay, so I've got 1/3 T plus 1/6 T is equal to 1. So I could add these two fractions together pretty easily. I'm going to put that up here because I'm going to make it in terms of sixths. That would make this 2/6. So 2/6 T plus 1/6 T is equal to 1. Then I can add those together. 2/6 plus 1/6 is 3/6, or 1/2 T is equal to 1. And to find T, and T would be in hours, I'm just going to multiply both sides of the equation by 2. And that would give me T is equal to 2 hours. Okay, and it seems that my iPad is hung up right now, so I'm going to stop after this point, and I'm going to go ahead and let me see if I can get back in there. Oh, there we go. And go to the next problem. It takes one person 4 hours to proofread a copy. It takes a second person. If a second person is employed, the job can be done together in 2.5 hours. How long does it take the second proofreader to do the same job alone? So the first person's rate, here's the first person. He does one job per 4 hours. And the second person, you don't know his rate, but we're going to put in the same unit. We don't know, it's so many, but we know that the time working together to finish the one job is 2.5. So in this problem, we're just going to have 1.5, 1.4, it'll be job per hour, because they're working together. Job per hour times 2.5 hour plus, we don't know, so we need a variable for this. And so we could use, I don't want to use T for time. I'm going to use R, capital R, for rate. Gianna, jeez. Okay, almost. Is it rate of the second worker? So then we have R times 2.5 hours is equal to, we're going to finish the whole job together there, okay? So now all we have to do is say 1/4 times 2.5. So what is 2.5 divided by 4? And take a second to get that. So 2.5 over 4 plus 2.5 R, and that's what we want to solve for, is equal to 1. So if I take, and my calculator is in the other room, so I'm going to try to use the calculator here, and I have 2.5 divided by 4 is 0.625, 2.25 plus 2.5r is equal to 1. So then I have 2.5r is equal to 1 minus 0.625. And then I just have to divide by 2.5. And so if I do that, the 2.5's cancel. And we get 1 minus 0.625. And then we're going to take that and divide it by 2.5. And it looks like my answer is R is equal to 0.15 jobs per hour. So now if I change that over, you know that that's 15 over 100. And if I simplify that, it's 3 over 20 jobs per hour. So I'm going to stay on by that answer and check it later, but I'm getting a little bit long in the video right now, so I'm going to stop there and pick up with functional notation on question number 16. Okay, that's it for now, and I'll check in with you later. Bye.